Hello. Okay, so today you have watched Bill Nye and you have taken a quick quiz on Bill Nye. And now you're going to work through a Google slide for sound. Okay, so using your notes as well and then any knowledge that you gained from Bill Nye, you are going to drag these to the vocabulary matching. So you got this is a little bit longer than what ones we've done in the past, but it's got a lot of information there. All right, so I'm going to work a couple of these with you, and then what I do, I'll just leave, and then you won't have to do those. Okay. So match the definitions to the vocabulary term. All right, a compression wave, molecules, frequency, pitch, matter, and wave. A group of two or more atoms that are bonded together. Okay. Well, that's going to be molecule. We've not talked about that a whole lot, so I'm going to give you that one. That is a molecule. Let's see. Anything that occupies space. What is that? That is matter. How high or low a sound is. How high or low. We've talked about that a whole bunch, so I'm going to leave that one for you. Sound travels as this. I'm going to leave this one for you. A repeating up and down or back and forth movement of matter. What do you think that would be? Okay, that's going to be the frequency, which goes hand in hand with pitch. And then the number of wavelengths per second. Okay, I want you to fill those three in. Okay, and let's go on to the next one. All right, match the answer to the question. What is sound? What medium can sound travel through? What causes sound? What form does sound travel? All right, what is sound? Caused by vibration matter, gases, liquids, and solids, a compression wave, a form of energy carried by sound waves. All right, let's see. I think I want to go with gases, liquids, and solids first because I know that that is the medium that sound can travel through. Okay. What causes sound? What causes sound? That would be it's caused by vibrating matter. And what form does sound travel? A compression wave. And then the form of energy carried by sound waves is sound. Okay, so we did all that one together. Not terrible, right? All right, phases of matter. Drag the definition to the phase of matter. I'm not going to do this one. I think that you guys can do these spread out molecules, freely moving molecules, tightly packed. One of those will go into each of the columns. Sound travels best in this phase. Sound travels slowest. So only one of them is only going to have one. And then two will have two. Okay. So in other words, you have to do that whole slide. Travel of sound, drag the blue box to each blank to finish the sentence correctly. Okay, I'm going to leave this one for you as well. Sound travels through blank. So which one does make sense? Sound travels best in solids because molecules are... Finish that sentence. Sound travels the slowest through gases because the molecules are... Finish the sentence. And there is blank in space because there are no molecules or matter for sound to travel through. Okay, we talked about that in our notes yesterday. All right, vocabulary. Match the definitions to the vocabulary term. Compression and wavelength. I'm not going to do this one for you either. I think that you'll be able to figure that one out with your notes. Label it compression wave. Label the wavelengths and the compression in the bottom of the wave. So you have to type it. What's happening here? Oh, you have to type. Duh. All right, Miss Connor. So you're just going to type that in. So what's this part right here? Well, let's do this one together. So when they clump together, that is called compression. When they break apart, That's called refraction. Okay. It could also be wavelength, but wavelength is actually one of these to the other. Okay. All right. Pitch and volume. So we talked about this yesterday. Amplitude and frequency. Sort the blue boxes. All right, so amplitude and frequency. Remember, amplitude is how loud or how soft something is. Frequency is the pitch, how high or low something is. So amplitude would be, this would be loud amplitude. This would be soft amplitude. Low, small. Frequency would be high frequency, a high pitch. This would be a low frequency, a low pitch. All right. Size of vibration, speed of vibration. So we'll do this one together. Size of the vibration is going to be amplitude, okay? And speed of the vibration is frequency, okay? How often it happens. I'll leave these two for you. You can tell me which one determines the pitch and which determines how loud a sound is. Again, I'm going to leave this one for you. Drag the answers to complete the paragraph. Label a wave. You did that yesterday, so you can do that again. All right, what did you notice? Answer the questions below about the volume waves. What did you notice about the waves? Okay, you're going to click to answer those 3 questions. All right, now this one is new. We've not done something like this. So you're going to use this website to answer the questions below. So the questions are, when an object vibrates more slowly, the pitch will be, what is an example of a high-pitched sound? When an object vibrates quickly, the pitch will be, what is an example of a low-pitched sound? Okay, so when you want to use the website, you click on it with your left click, and then click. It should take you to it. Hopefully you don't have an issue with the SonicWall. And if you do, just let me know, okay? And you're going to use this to answer the questions. That's all you have to do is this one page, okay? And then so answer those questions using that web page. Same thing. I want you to answer the questions below about pitch waves. What do you notice about the waves? What will the waves look like for a low pitch sound and a high pitch sound? Please don't put just one word. Think about it. Put a complete sentence. All right, musical instruments. Musical instruments vibrate to produce sound. What are the 4 classifications of musical instruments? Guys, we talked about this yesterday, so use your notes. You're only going to use 4, okay? 4 of these right here, so use your notes. Because I know that we talked about that. I know that we put it in there. So, yeah, all right. Make sure I called it the same thing. So you're only going to put 4 of these in here. Again, you're going to use a website to answer questions, okay? Click it with your left, and then click what it brings up. And then it tells you right here. You might be able to even click on, so you're going to click on Woodwind, and it's going to tell you how it works, okay? Which is really cool because we talked about this yesterday with the reed and then brass. That's super cool, right? Okay. All right, so finish that. And then the last thing you're going to talk about is animals. Animal hearing. Drag the answers to complete the paragraph. Many animals hear noises above or below the what? We'll do this one together. Many animals hear noises above or below the human range. Animals can make sounds that humans cannot hear. The animal, the smaller the animal, the higher the range. If you think about a mouse, how little a mouse is, and they're, but you think about a whale, and they are like in Finding Nemo. All right. Echoes. Echoes are the result of waves that hit a blank surface and bounce off. I think you guys can do this. We talked about echolocation with bats yesterday, so you'll be able to do that. And tell me what's happening in this picture, okay? And then the same thing here. You're going to click your left, click the page, and then it opens up. You can exit out of that. And then, can you hear that? No, but a porpoise could. Oh my gosh, I love those kind of jokes. All right, so this gives you the range of animals and what they can hear. All right. So you can use that to answer those questions. Okay. Lowest range, highest range of a bat. Lowest range, highest range of a dog, dolphin, and a human. All right. And once you are finished, that's it. That's the last one. Then you go back to Canvas and submit. Need me? Let me know.